Hello everyone, welcome to Einstein's Riddle puzzle part 3. So in this video I'll be talking about how we can solve Einstein's Riddle problem in a case where instead of having 5 houses along a line, we're going to assume that there are 5 houses around a circle. In other words, if you look at this figure, house 5 is next to house 1. So this is in contrast to linear configuration of the houses where house 5 was not next to house 1. So if you assume this modification to Einstein's Riddle problem, the question now is whether the solution is unique or not, and if it is not unique, what are the possible solutions? So we're going to use the technique we applied to the linear case, which was integer programming. So we're going to use the same technique now to solve this problem where the houses are arranged around a circle. Okay, so I'm going to just talk about the modifications to the formula as well as the modifications to the MATLAB code that we developed in part 2 of this video. Okay. So I just quickly jump to the modifications. So to account for the periodic boundary conditions in this case, where house 5 is next to house 1, we're going to assume extra variables. So the variables that we're going to consider here is for every color, okay, or for every nationality, or for every cigarette or pet or drink, we're going to assume another variable, okay, that is identical to the first variable. So let's say for color, okay, let's say for blue, I'm going to assume that there is a 6 variable, x16, which is identical to x11, okay. Or for, let's say, green color, I'm going to assume in an extra variable x26, which is identical to x21. So I'm going to assume the same thing for all 25 variables. In other words, initially I had, let's say, for color, if the first one was blue, I guess, if I had 1, 1 through 1, 5 for a linear case, excuse me, for a circular case, we're going to have x11 to x16. So the 6th variable is the modification we applied here, which is identical to x11. Similarly, for green, we're going to consider an extra variable x26, which is identical to x21. Okay, and so forth. So if we're gonna assume an extra variable for all category, okay, and the constraint for these variables are that the 6th variable is identical to the first one only. Okay, so this actually brings in the periodic boundary conditions. All right, so we're gonna have 150 variables instead of 125 because we're gonna add 25 more variables. Okay, now with this, we can just go through the same conditions. So all conditions will be identical. That means we only apply the conditions to x1 to x5 instead of x1 to x6. So we do not apply to x6 because x6 is identical to x1. Okay. So the conditions we had in part 2 of this video, where we applied the constraint to the linear arrangement of the houses, will apply to the circular arrangement. There are only a few changes that I'm going to talk about. Other constraints are exactly identical. Okay, so the first constraint that is different now is the condition number 4, which was greenhouse is to the left of the White House. So let's see how we can impose this in the circular arrangement. In this case, okay, we initially had j times x2j, so this is the green. So these are the variables to pick up the number of the greenhouse. All right, and then j times x4j is going to pick up the house number for the White House. Okay, so given that we have 6 variables for green and white, since the result of that is going to be negative because house green is to the left of the White House, for the green, we're going to sum over j1 to 5. And for white, we're going to sum from J2 to J6. Okay, the reason is now if let's say the first one, which is the greenhouse, is 5 and the next one is 6, then we can generate -1 again, which means we can consider green to be to the left of the White House. Okay, so that's the trick. For the first term, we just sum over 1 to 5, when j goes from 1 to 5, and then for the second term, we just sum over 2 to 6. Similarly, let's say for condition 10, where the man who smokes blends lives next to the one who keeps cat. Okay, so initially we had j1 to 5 for the linear arrangement. We had j1 to 5, and then j times the house number for the person who smokes blends minus the house number who keeps cats. Okay, now, so this is the condition we had for the linear case. How we can change this to the circular arrangement? We only have to consider two cases where the absolute value is positive or negative. If it's positive, that means the first term is bigger than the second term. So we're going to sum over 2 to 6 for the first term, and then 1 to 5 for the second term. So that's exactly what I'm talking about. The first term goes from 2 to 6. The second term goes from j1 to 5. So this is where the first term is bigger than the second term, where we can remove the absolute value. If the first term is less than the second term, then the first term will be summed from 1 to 5, and then the second term will be summed from 2 to 6. So that's the only difference. Okay. Again, we should consider 16 cases, same as linear arrangement. The only thing is whenever we have positive, the first term is bigger than the second term, so we sum from 2 to 6 for the first, and then 1 to 5 for the second. In contrast, if the integrand, or sorry, the term in the absolute value is negative, then the first term is less than the second term. So for the first term, we sum over 1 to 5, and then for the second one, we sum over 2 to 6. Okay, we apply the same technique to the other conditions. The man who keeps horses lives next to the man who smokes downhill. Do the same thing. If it's positive, the first term goes from 2 to 6, the second term goes from 1 to 5. If this is negative, or the inside the absolute value is negative, then the first term will be sum over 1 to 5, the second term would be 2 to 6. Okay? Okay, so we had two more conditions, we do the same thing, and then, right. So now in this case, pretty much we do not have any objective function because we already accounted for each of these conditions to be positive or negative. So when we go to MATLAB script, for the objective function, we do not enter anything. So the objective function will be blank, and we have all conditions entered in the equality conditions or equality constraints. We do not have any inequality constraints. Okay, so let me now jump to MATLAB script, but before doing that, just emphasize the discretization of the x in this case is going to be 100 to 150 variables because we added 25 more. Okay, and as I said, the objective function will be empty. Everything we have is just equality constraints. We do not have any inequality constraints or objective function. So let me just quickly walk you through the MATLAB script. So this is the MATLAB script we developed for the linear arrangement. For circular arrangement, we pretty much do not change anything until we get to the condition where the greenhouse is next to the left house. So the first term goes from 1 to 5, the second term goes from 2 to 6, whose sum will be -1. So the right hand side is going to be -1 because green is to the left of the white. And then the other changes is we have to apply the 25 more constraints we added. The 6 variable for every category is equal to the first category, and that's what's implemented here. Okay, so I'm going to add 25 more constraints. These are equality constraints, and I'm saying that, for example, if you go back to the numbers here, I would say x6 is equal to x1, x12 is equal to x7, x18 is equal to 13, 24 to 19, 30 to 25, and so forth. Okay, and that's exactly implemented within this loop right here. Okay, now we're gonna go over the 16 cases depending on inside the absolute value being positive or negative, because we have 4 absolute values, so total is going to be 2 raised to the 4th power, and total is going to be 16 cases, right? In every case, we have to assume whether an absolute value is positive or negative. If the absolute value is positive, then the first term goes from 2 to 6, the second term goes from 1 to 5. If the absolute value is negative, then the first term goes from 1 to 5, the second term goes from 2 to 6. Okay? That's the only change we do, and again, our objective function is going to be empty. So I do not have anything as objective function because I consider all the constraints to be equality constraints. All right, so this is pretty much like a linear system to solve, but we use this in integer programming context because all variables are either 0 or 1. Okay, we cannot just simply go ahead and solve the linear system because in that case we get real variables or real values for the variables. Okay. Anyways, so I think this is it. That's the only change. If I run this code, then you see that it's going to return actually 7 possible cases. So that's in contrast to the linear arrangement where we have only one solution to the Einstein's Riddle problem. In this case, we have 7. Okay, and so when you run this code, it actually generates, it goes over the 16 cases, but it only prints out the result if all conditions are satisfied. And so, so see, it has gone through 16 cases, but it found only 7 solutions. Okay, so these are the solutions right here. So yeah, I hope this is useful. Stay tuned on the next video for other problems or puzzles similar to Einstein's Riddle problem. Thanks for watching.